So friends, now we are discussing the equation of tangent to the parabola in three different forms. The first form is the slope form of the equation of the tangent. The second form is point of contact form of the equation of the tangent. And the third form is parametric form of the equation of the tangent. So we will discuss step by step. So let's start the first point. So the first point is equation of tangent in slope form. As we know, the slope form means what? The slope of the tangent is given. Okay, we know if the equation of the parabola is y square is equal to 4ax and any tangent on it has slope m, then the equation of the tangent can be written in the form of y is equal to mx plus a by m. Okay, and the point of contact will be a by m square comma 2a by m. Okay, now write the things, that is the equation of tangent whose slope is m, that is tangent has slope m, to the parabola y square is equal to 4ax. So equation of the parabola is y square is equal to 4ax, can be written as y is equal to mx plus a by m. Okay, so look here, only the equation of tangent depends on m and a is known. We know y square is equal to 4x, we will get the value of a, and the point of contact will be is a by m square comma 2a by m. So in terms of m, the point of contact is a by m square comma 2a by m. Got it? So look, just let me clear through the diagram this. This is the parabola whose equation is given as y square is equal to 4ax. Okay. So if we draw a tangent on it, so suppose this is the tangent and its slope is given as m. Okay. So what will be the equation of this tangent? The equation of the tangent will be y is equal to mx plus a by m, and this point of contact has coordinate a by m square comma 2a by m. Okay, so these are two important equation, that is y is equal to mx plus a by m is the equation of tangent in slope form, and its point of contact is what? A by m square comma 2a by m. You must remember these equations and this point of contact for the numerical. Okay, now we are going to prove, that is how the equation of the tangent in slope form become y is equal to mx plus of a by m, and how the coordinate of the point of contact become a by m square comma 2a by m. Okay, so please look. So let's prove. Our equation of parabola is y square is equal to 4x. This is known. And as we have to find the equation of the tangent in slope form, that is slope of the tangent if it is m, then the tangent line can be written as y is equal to mx plus of c, where c is unknown. That is, we have to find the value of c by applications of the condition of tangency. Okay, so look, let the tangent is y is equal to mx plus of c. So here M is known and C is unknown. And it is given the parabola is and it is given the parabola is y square is equal to 4ax. Okay. Now, if we solve this equation 1 and if we solve this equation 1 and equation 2, we'll get a single value of x and single value of y. That is, we'll get only one point which is common to both of this curve, is not it? And that common point will be what? The point of contact, is it? So, from equation 1 and 2, we get mx plus of c whole square is equal to 4ax. That is, we just shift the value of y as mx plus c in this second equation. So, we get mx plus of c whole square is equal to 4x. Now, this is nothing but a quadratic equation of x. Now, how many values of x we will get? We will get two values of x as quadratic equation, so two roots, but these two roots are real and equal. Why these are real and equal? Because the value of x, that is roots of this equation, will be the x coordinate of the point of contact. That is, this quadratic equation has only one root, you can say also. And for this, we can say the discriminant of these quadratic equations will be 0. And this discriminant is equal to 0 is the condition of tangency. Okay. So, writing m square s square plus 2mc into x plus of c square is equal to 4x. Okay. Just we expand it. In the next step, we can write m square s square plus 2 into mc minus 2a into x plus of c square is equal to 0. Now, if we give the name of this equation is 3, so equation 3 has discriminant is equal to 0. Why? Because this equation must have only one root, that is two real and equal root. So, clearly D is equal to 0 for equation 3. So, applying D is equal to 0, what is discriminant? It is b square minus 4ac form. So, we can say b square, that is 4 into mc minus 2a whole square is equal to 4ac, that is 4a is here m square and c here c square. So, we can write this is 4m square c square. Okay. So, we can cancel 4 from both sides. So, we get mc minus 2a whole square is equal to m square c square. Okay. So, if we expand it, we will get the value of c is equal to a by m. So, what will be the value of c? The value of c will be a by m if the discriminant becomes 0. That is the condition of tangency if we apply. So, the equation of the tangent becomes what? Y is equal to mx plus c. That is, if we substitute the value of c by a by m, we will get y is equal to mx plus of a by m will be the equation of tangent. So, writing here, therefore, substituting c by a by m in equation 1. Okay. So, substituting the value of c is equal to a by m in equation 1, we will get the equation of tangent. So, we get the equation of tangent as what? y is equal to mx plus c is equal to a by m. So we will write a by m. So this is the equation of tangent. Okay. So we prove it regard the equation of the tangent in slope form. Now to find the point of contact, just from equation 3 we will find the x coordinate of the point of contact. So how? From equation 3, again from 3 we get what? The value of x is nothing but what? Minus b by 2a, as the discriminant is equal to 0. Okay, so the value of x will be what? Minus 2 into mc minus of 2a divided by 2 into m square. Is it? So this x is nothing but the x coordinate of the point of contact. Here c is unknown, so we have to substitute the value of c by a by m. So we get the value of x is equal to minus mc is what? mc is equal to a, so we can write this is a minus 2a divided by m square, that is a by m square. So the x coordinate of the point of contact will be a by m square. Understand? Now how we get the y coordinate of the point of contact? If we substitute this a by m square in the equations of tangent, we will get the value of y. So therefore, substituting x is equal to a by m square in the equation of tangent. Okay, what we will get? We get y is equal to m into x. And what is x? X is equal to a by m square. So writing a by m square plus a by m. So we are writing a by m. So what is the value of y? Clearly the value of y will be a m by m square, that is a by m, plus of a by m, that is equal to 2a by m. So we are writing this is as 2a by m. So this x and y are nothing but what? The x and y coordinate of the point of contact. Is it? So the point of contact we can write, therefore point of contact is a by m square comma 2a by m. Understand? So in this way we can find the equation of tangent in slope form and its point of contact in terms of m. It is clear? Okay. Now we are coming for the equation of tangent in point of contact form. Okay. So let's have a look. So friends, now we are discussing the equation of the tangent in point of contact form. That is, when the point of contact given. If the equation of parabola is y square is equal to 4x and the point of contact is x1 comma y1, then the equation of tangent drawn at x1 y1 can be written as y into y1 is equal to 2a into x plus of x1. Okay. And the point of contact is x1 comma y1. So let's write equation of tangent in point of contact form. So point of contact form means the point of contact is given. Is it? So equation of tangent to the parabola. The parabola is y square is equal to 4x we are considering. So parabola y square is equal to 4x drawn at x1 comma y1. That is the x1 comma y1 point is the point of contact. Drawn at x1 comma y1 can be written as y into y1 is equal to 2a into x plus of x1. Okay. So you please remember this form. Very important for your numerical. Okay. Clear? This form is also known as what? Capital T is equal to 0. We already learned about this form in the study of equation of tangent to the circle also. Is it? So this is also known as y1 minus 2a into x plus of x1 is equal to 0, or you can say capital T is equal to 0. Okay, so capital T is equal to 0 form. We all know capital T is equal to 0 is always represents the equation of tangent in point of contact form. Okay, you just see the trick we already previously discussed, that to find the equation of tangent in point of contact form, just we substitute x square by x into x1. Y square by y into y1, x by x plus x1 by 2, y by y plus y1 by 2, and we keep the constant as same. So here also the short trick is the curve is y square is equal to 4x. Okay, so the tangent drawn at x1 comma y1 can be found by what? By substituting x by x plus of x1 by 2, okay, because only x is there, and y square by y into y1. Is it clear? As only x is there, so we write x plus x1 by 2, and as only y square is there, so we write y into y1 by 2. So what will be the equation of the tangent? Therefore, equation of tangent is look, we are substituting this y square by y into y1 in the equations of curve, and is equal to 4a, x is substituted by x plus x1 by 2. So we are writing x plus of x1 by 2. So this is simply y into y1 is equal to 2a into x plus of x1. Got it? So this is the way to find the equations of tangent in a short way in the point of contact form. Okay, so just shift x square by x into x1, y square by y into y1, x by x plus x1 by 2, and y by y plus y1 by 2. If xy is there, then xy by xy1 plus yx1 by 2, and keep the constant as it is in the equation of curve, and we'll get a linear equation which will represent the equation of the tangent drawn at x1 comma y1 to the curve. Is it? So we'll prove this in another way also. So look at the details, that is how we can prove or how we can achieve these equations directly. Okay, so look how to prove the equation of tangent in point of contact form in another way, basically the theoretically. So the proof is, just we draw the curve, that is y square is equal to 4x. Okay. So in the previous discussion, we discussed that if the slope of the tangent is m, then the point of contact of tangent will be what? A by m square comma 2a by m. So we are drawing a tangent. As we already proved, if the slope of this tangent is equal to m, then the point of contact will be a by m square comma 2a by m. Is it? Now, we are considering that the point of contact here is x1 comma y1. So, the point of contact is x1 comma y1. So, x1 comma y1 is nothing but what? A by m square comma 2a by m, that is x1 is equal to a by m square and y1 is equal to 2a by m. Okay. So, calculating clearly, x1 comma y1 is equal to a by m square comma 2a by m. Okay. So, what we can write? We can write y1 divided by x1 is equal to 2a by m by a by m square. Is it? So, this is nothing but 2m. Okay. So, what is the value of m? The value of m is equal to y1 divided by 2x1. Is it? Now, you just multiply it by y1 in both numerator and denominator of the right hand side. So, what we will get? y1 square divided by 2x1 y1. Now, what is y1 square? y1 square is equal to 4ax1. Why? As x1 y1 lies on the curve, y square is equal to 4x. So, x1 y1 satisfy this equation, y square is equal to 4x. So, we can say y1 square is equal to 4ax1. So, what we can write? We can write the slope m is equal to, instead of y1 square, we just writing 4ax1. So, this is 4ax1 divided by 2x1 y1. Okay. So, what is m? M will be 2a divided by y1. So, we get the value of m is 2a by y1. Okay. So, slope of the tangent drawn at the point x1 comma y1 can be written as 2a by y1. Now, come to the equation of the tangent. As the slope we already get, that is slope of the tangent we get, and the tangent is passing through the point x1 comma y1. So, we can write the equation of the tangent in point slope form. Okay. So, what we can write? Clearly, equation of tangent is y minus of y1 is equal to m into x minus x1. This is the point slope form of the equation of line, and here the line is the tangent line. Okay, as the tangent line is passing through the point x1 comma y1, where x1 comma y1 is the point of contact and has slope m. So, we write y minus y1 is equal to m into x minus x1. Now, we get the value of m in terms of y1 is 2a by y1. So, we will substitute the value of m by 2a by y1 here. So, what we can write? Y minus of y1 is equal to 2a by y1 into x minus of x1. So, we get the equation of tangent in terms of x1 and y1. Now, we will write in the simplest form. So, to do this, just you multiply it by y1, we will get y into y1 minus y1 square is equal to 2a into x minus of x1. Okay. Now, what is y1 square? y1 square is 4a into x1. As I told you, x1, y1 lies on the curve y square is equal to 4x. So, the equations of the parabola, that is y square is equal to 4x, satisfied by x1, y1, that is y1 square is equal to 4ax1. So, writing y1 minus substituting this y1 square by 4ax1. So, we are writing this is as 4ax1 is equal to 2a into x minus of x1. Now, shift this minus 4ax1 in the right hand side. What we will get? We will get y1 is equal to 2a into x plus of x1. Okay. So, this is the equation of tangent in point of contact form to the parabola y square is equal to 4x. Okay. Where the point of contact is x1 comma y1 and the equation of the tangent is y1 is equal to 2a into x plus of x1. Understand? Clear? Now we are coming for equation of tangent in parametric form. That is, so discussing the equation of tangent to the parabola y square is equal to 4x in parametric form. Okay, so equation of tangent in parametric form. As we all know, the tangent in parametric form means the point of contact is given as parametric form. Okay, so we know the any point to the parabola y square is equal to 4x is 80 square comma 280. So if we consider 80 square comma 280 is the point of contact, then equation of the tangent to the parabola y square is equal to 4x will be y is equal to x by t plus of 80. Okay, so and we will prove this also. So look, equation of tangent to y square is equal to 4x drawn at 80 square comma 280, that is the point of contact is 80 square comma 280, and we have to draw the tangent to y square is equal to 4x. The equation will be is y is equal to x by t plus of 80. Okay, so y is equal to x by t plus of 80. This is the equation of tangent. So if we draw it, it will be clear to us, and togetherly we will prove this also. So look how to prove this. So going to prove this, first of all we will draw a parabola and we will draw the tangent. So look, so this is the coordinate system, and the parabola y square is equal to 4x is like this. Okay, so this is the tangent. The point of contact of this tangent is 80 square comma 280. So this point of contact can be written as 80 square comma 280. Okay. Now how to prove the equation of the tangent will be y is equal to x by t plus of 80. Look how. We know equation of tangent in point of contact form, that is if the point of contact is x1 comma y1, then equation of the tangent to y square is equal to 4x is y1 is equal to 2a into x plus of x1. Here 80 square comma 280 is considered as x1 comma y1, is it? So substitute just x1 by 80 square and y1 by 280 in the equation. Y1 is equal to 2a into x plus of x1. We will get this equation of tangent. So we know equation of tangent to the parabola y square is equal to 4x drawn at x1 comma y1 is y1 is equal to 2a into x plus of x1. We already proved this in the previous discussion. Now if we substitute x1 by 80 square and y1 by 280 in these equations, we will get the equation of the tangent in parametric form. So substituting x1 by 80 square and y1 by 280, okay, in this equation we get the parametric form of equation. Parametric form of equation. Okay, so let's substitute. So what we will get? Y1 is substituted by 280. Y into 280 is equal to 2a into x plus x1 is substituted by 80 square. So we'll write 80 square here. Okay. So just cancelling 2a from both sides and divide both sides by t. We'll get y is equal to x by t plus of 80 square. Okay. So this is nothing but the equation of tangent in parametric form. Okay. Folks, point of contact is 80 square comma 280. Understand? And what is the slope of this tangent? The slope of this tangent is 1 by t, because this is nothing but in the form of y is equal to mx plus of c. So m is the slope, which is 1 by t. So we can say the slope of this tangent is 1 by t. So writing here again, this is important. So important is slope of this tangent. Slope of this tangent is is 1 by t. So remember this thing also, that is in the parametric form the slope of the tangent will be 1 by t. Okay, this will be helpful for finding the equation of the normal in parametric form. Okay, so in this way we can find the three form of the equation of the tangent, that is slope form, the point of contact form and the parametric form. Okay, now we'll discuss about the alternative definitions of the directrix of the parabola, or we'll show the locus of the point of intersections of any pair of perpendicular tangent to the parabola is the directrix. Okay, so look what it is. So friends, now we are discussing the locus of point of intersection of a pair of perpendicular tangent to the parabola. Here we learn the locus of point of intersections of any pair of perpendicular tangent to any parabola will be the directrix of the parabola. Okay, so look the discussion. The locus of the points of intersection of any pair of perpendicular tangents. Okay, so this is the heading. So what we say? The locus of the points of intersection of any pair of perpendicular tangents to the parabola will be its what? Directrix. Will be its directrix. Okay. So this is also the alternative definitions of the directrix of parabola. So alternatively we can also say that from any point on directrix we can draw a pair of perpendicular tangent to the parabola. Okay, clear? So look how we can discuss this theoretically. We know equation of any tangent to the parabola y square is equal to 4x can be written as y is equal to mx plus a by m. And what is m? M is the slope of the tangent. So where m is the slope of the tangent. Slope of tangent. Okay? We know it. So let's draw it for better understanding. Suppose this is the parabola whose equation is y square is equal to 4x. Okay. So if we draw any tangent to this parabola, so equation of this tangent can be written as y is equal to mx plus a by m if its slope is m. Is it? Now, if this tangent is passing through a fixed point, so suppose a tangent, this tangent passing through a fixed point, not only fixed point, now if this tangent is passing through a point h comma k, so just draw here the point h comma k. So through this the tangent is passing. So the equation of the tangent y is equal to mx plus of a by m must be satisfied by the point h comma k. Okay, so we are writing if this tangent passing through an external point h comma k, then the equation of tangent, what is equation of tangent? It is y is equal to mx plus a by m. So y is equal to mx plus a by m satisfy h comma k. Definitely it is. Okay, so satisfying it, what we will get? This implies k is equal to m into h plus a by m. Is it? So substitute x and y by h comma k, we will get k is equal to mh plus a by m. This is nothing but a quadratic equation of m. So just make it m square h minus k into m plus of a is equal to 0. So we write as a perfect quadratic equations of m, we get m square into h minus k into m plus a is equal to 0. Okay. So this equation must have two roots, what? m1 and m2. So this equation must have two roots, say m1 and m2. Is it? Now what does this refer? This refer, that is, this equation must have two roots m1 and m2. This refer from the external point h comma k, we are able to draw a pair of tangent, that is two tangent to this parabola. Okay, and one of the tangent has slope m1 and another tangent must have slope what? m2. Okay, so let's draw. So we draw two tangent. Look, we are able to draw two tangent. So this tangent has slope is equal to m1 and this tangent has slope is equal to m2. Understand? Clear? Okay. Now, if these two tangents are perpendicular, in that case what happens? The product of the slope of these two lines will be -1. Okay, and we will use this property. So, we are writing if these tangents are perpendicular, then obviously m1 into m2 become what? -1. Look, this is the property of perpendicular tangent. Now come to the equations of this quadratic form. M square h minus km plus of a is equal to 0. This equation has two roots, m1 and m2. So what will be the product of the roots? m1 into m2 will be a by h. Is it? So we can say what? So we can say, therefore, we can say m1 into m2 is equal to a by h. Understand? From this equation we will get, as this equation has two roots, m1 and m2, and this is equal to what? -1. So what we can say? We can say h is equal to minus of a. Is it? So we get h is equal to minus of a. So this is nothing but the locus of the point hk. So what is the locus of the point hk? We can say just substitute h by x, we will get x is equal to minus a. So we can write in this way, therefore locus of h comma k is x is equal to minus a. So locus of h comma k will be x is equal to minus a, and this is nothing but x is equal to minus a is nothing but the directrix of the parabola. Is it? So look, I am drawing the directrix. So this is the directrix of the parabola, and we all know the equation of the directrix is x is equal to minus a. Is not it? So we can say if these tangents are perpendicular, then their point of intersections will lies on the directrix of the parabola. Or alternatively, we can say from any point from the directrix of the parabola, we are able to draw a pair of perpendicular tangent to the parabola. Got it? So locus of the point of intersections of any pair of perpendicular tangents to the parabola will be its directrix. Okay? So remember it. Now come to the another concept.